Okay, we're going to start with last night's assignment first. The funny answer to the riddle, why did they try to build a house on Mr. Colby's head, is he had a lot on his mind. And the comedy part comes in the dual meaning of lot and a lot. Okay, now if you got this or most or all of it and you feel confident that you understand how to solve inequalities and when you should and when you should not reverse the inequality symbol, you can skip forward to the next slide. If not, you should hang out here for a minute while I go over each and every problem on that assignment in a different way and see how this works. So these are all the problems. Let me zoom out for a minute. That's not what I wanted. Oh, I am zoomed out. That's not good. Okay. Anyway, if as you were doing these, you notice that your lines did not go through a number and a letter, you may have realized something wasn't going well, and you can go back and check your work. But let's go over these just to show you that I don't just ask you to show your work neatly and well. Here's mine on scratch paper. Number 1 was 3x plus 8 is greater than 2. Subtracted 8 from both sides to get rid of the constant term and to isolate the variable term. 2 minus 8 is the same as 2 plus negative 8. That's negative 6. And I did not need to reverse the inequality symbol because I didn't divide or multiply by a negative. Then I divided by 3. That's dividing but not by a negative. And so even though my quotient's negative, again, I should not reverse the inequality symbol because I did not divide by a negative. I divided a negative number, my divisor, no, my dividend, but my divisor, the number I'm dividing by, was not a negative, so I do not reverse the inequality symbol in that case. I promise you I won't give you all those details for every single problem, but at least for the first few I think it will be helpful. On number 2, 7x minus 1 is less than 20. So you get rid of that constant term on the side of the inequality with the variable by adding 1. Negative 1 and 1 is 0, and the constant term goes to 0. We're left with 7x is less than 21. We didn't multiply or divide by a negative, so I do not reverse the inequality. Then I divide both sides by 7. Multiplicative inverse, property of equality. I get 1x, which is x, is less than positive 3. Again, we did not need to reverse the inequality symbol because we did not multiply or divide by a negative. Number 3, 8 minus 4x is greater than negative 12. Now the constant term is shown first. That's no problem. I get rid of 8 by subtracting 8 or by adding negative 8 because 8 minus 8 is 0. But the tricky part here, the part that gets a lot of students is when you get rid of this constant term, you still have negative 4x. You don't have 4x because we were subtracting 4x, and that's the same as adding the opposite of 4x, which of course is negative 4x. On the other side, negative 12 minus 8 is negative 20. When we divide both sides by negative 4, to get rid of this coefficient, to turn the coefficient of x into 1, we're dividing both sides by a negative, so we have to reverse that inequality symbol. Greater than becomes less than. So x is less than 5. Number 4, negative 5x minus 9 is greater than or equal to negative 4. You add 9 to both sides. Negative 4 plus 9 is 5. I still have this variable term, negative 5x, and I make it 1x by dividing by negative 5. Divide both sides by negative 5. I divided by a negative, so I reverse the inequality symbol. Greater than or equal to becomes less than or equal to. And 5 divided by negative 5 is negative 1. There's a lot going on here. I'm not sure why, but number 5 was 63 plus 12x is less than 15. You subtract 63 from both sides to get rid of the constant term, and you're left with 12x on the left side of the inequality, and on the right side, negative 48. When you divide both sides by positive 12, the quotient on the right side of the inequality is negative 4. Even though that's negative and the dividend was negative, our divisor, the number we were dividing by, was positive, so we do not reverse the inequality symbol. X is less than negative 4 for number 5. Number 6, negative 8x plus 25 is less than or equal to negative 31. I get rid of the constant term by subtracting 25 from both sides of the equation. Negative 31 minus 25 is negative 56. I still have negative 8x on the left side of the inequality. When I divide both sides of the inequality by negative 8, I get x on the left side and positive 7 on the right. But I divided by negative, so I reverse the inequality, and we get x is greater than or equal to 7. I'm starting to wonder about something. Let me just peek over here for a minute. Oh, good. Okay. I was worried that I did something with that. Okay. Number 7. Negative 10 plus 2x is greater than or equal to negative 52. I remove the constant term by adding 10 to both sides. So when you add opposites, you get a sum of 0. That's additive inverse. Do it to both sides. That's property of equality. And I get 2x is greater than or equal to negative 42. When I then divide both sides by positive 2, I have not divided or multiplied by a negative, so I don't reverse the inequality symbol, and I get x is greater than or equal to negative 21. Now, number 8, the variable expression is on the right side of the inequality. Some students like to rewrite that, and if you rewrite that, here's how you do it. 6x minus 9. You don't flip anything in this expression, you just copy the expression. But then you imagine if you were comparing this expression to 15, when you look at this inequality, the original inequality as it's written, wouldn't this expression be less than 15? If 15 is greater than that expression, wouldn't the expression be less than 15? That's how you rewrite it if you want the variable expression on the left side. You just imagine you're reading from right to left, and this expression is less than 15. Okay, but I'm just going to solve them on the right side. There's really no reason to flip them around unless you're more comfortable with that. But if I just focus on the side with the variable, I'm going to remove the constant term by adding 9 to both sides. I get 24 is greater than 6x. I divide both sides by 6, and I get 4 is greater than x. And if 4 is greater than x, then x is less than 4. So when you're looking for the match on the sheet, you had to realize that if you start at the x and read it from right to left, it says x is less than 4. And so you rewrite it that way. Probably easier and safer to just rewrite it at the end once it's simplified all the way down. Once you solve for the variable by isolating the variable. Number 9 is 48 is less than 20 minus 14x. I want to subtract 20 from both sides to make this constant term 0. 48 minus 20 is 28. On the right side, you have to realize that when you remove this constant term, you still have negative 14x on the right side. And then when you divide both sides by negative 14, you get x on the right side. On the left side, you get negative 2 because positive divided by negative is negative. Not only that, we divided by negative, so we need to reverse the inequality symbol, which you see that there. And then if I read it from the x, it says x is less than negative 2. That's the final answer. Number 10, negative 60 is greater than or equal to 9x plus 3. Focus on the side with the variable. Subtract 3 from the constant term to make it 0. Subtract 3 from the other side of the equation because of property of equality. Negative 60 minus 3 is the same as negative 60 plus negative 3, which is negative 63. On the right side, we just have the variable term 9x. When we divide that by 9, we get 1x. 1x is x. And on the left side, when we do negative 63 divided by 9, we get negative 7. I was dividing by a positive, so I do not need to reverse the inequality symbol. When I read it from the x, it says x is less than or equal to negative 7. Now, let me just pause and say something. Well, I probably should have said at the beginning. I found out by testing this myself. You may have noticed, many of you did notice, I made a few errors in when I was going over the last homework and I was doing it on the fly and going a little too fast, made a few errors. And every time a student noticed an error and either emailed me or wrote on the discussion board, I was able to click on the video and pull that slider to where I needed to watch. So I believe you can get this feedback, this homework feedback, very efficiently by doing the same thing and looking for the problems that concern you the most. Number 11, 18 minus 10x is less than negative 22. Focus on the variable side, subtract 18 to remove the constant term. Remember that you still have negative 10x once you do that. And negative 22 minus 18 is negative 40. When we divide both sides by negative 10, negative 40 divided by negative 10 is 4, because there are 4 negative 10s in negative 40. On the right side, we get 1x, which is x, and we need to reverse that inequality symbol because we just divided by a negative. 12. 7 is less than 3x minus 8. Add 8 to both sides, and I get 15 is less than 3x. Divide both sides by 3, and you get 5 is less than x. None of the things we did were multiplying or dividing by a negative. When you read it from the x from right to left, it says x is greater than 5. That's the final answer for 12. 13. Negative 12x minus 8 is less than or equal to 64. Add 8 to both sides, removes the constant term, and you get negative 12x is less than or equal to 72. Divide both sides by negative 12, and you get x is greater than or equal to negative 6. We reverse the inequality symbol because we just divided by a negative. X is greater than or equal to negative 6. 17. The variable expression is on the right side. No problem. Remove the constant term from the variable expression. Add 45 to both sides. You get negative 7x on the right side. On the left side, negative 17 plus 45 is positive 28. When you divide both sides by negative 7, you get x on the right side. That's why we did it. On the left side, you get negative 4. We just divided by a negative, so I reverse the inequality from greater than to less than. And when you read from the x from right to left, now it says x is greater than negative 4. That's the final answer for 14. 15. 3x minus 42 is less than 0. Add 42 to both sides. You get 3x is less than positive 42. Divide both sides by 3. X is less than 14. That one was pretty straightforward. 16. 44 is greater than or equal to negative 8x minus 44. Focus on the side with the variable. Add 44 to both sides. 44 plus 44 is 88. And on the right side, we still have negative 8x. We divide by negative 8, and we get negative 11. Not greater than or equal to, less than or equal to, because I just divided by a negative. Negative 11 is less than or equal to x, which means x is greater than or equal to negative 11. 17. 4x plus 12 is greater than negative 24. I want to remove the constant term from the variable expressions, so I subtract 12 from both sides. On the right side, I get negative 36. On the left side, I have 4x. Divide both sides by 4. The inequality symbol does not get flipped, and we get x is greater than negative 9. 18, looks like I made a mistake here. Negative 17 is less than or equal to negative 6x plus 25. Add 25 to both sides, and I get negative 42 is less than or equal to negative 6x. Divide both sides by negative 6, and I get positive 7 is greater than or equal to x. Looks like the first time I did this, I forgot to flip the inequality symbol, but I just divided by a negative, so I need to reverse that inequality symbol. If I read it from the x is less than or equal to 7.